Alright, so in this lesson, we're going to go over Chapter 1, Section 4C. We're going to solve by using the quadratic formula. Now, we learned a couple other ways to solve quadratic equations. Alright, so in the first part of this chapter, we covered factoring and taking the square root on both sides. And then in the previous lesson, we went over completing the square. Now, solving by using the quadratic formula is something that's going to be applicable to any quadratic that you get, right? As long as you write it in standard form and you can label your A, B, and C, then you can use the quadratic formula with any quadratic that you encounter. All right, now this is the quadratic equation the quadratic formula. Now given a quadratic in standard form, remember, that's why weeks ago I stressed the importance of writing anything with an exponent of 2 in standard form, right, in decreasing exponents, because here these letters are going to be useful, right? A, B, and C are going to be useful in these situations, right, because our formula to get our values for x when we have an equation set equal to 0 is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. You do have to memorize this, right? So it might seem like a lot at first, but the more you practice it, the easier it'll come, right? For some of these problems, the hardest part is just remembering this formula, right? But once you got it down, then it should be pretty easy from here. All right, let's try some examples. Now, your instinct with all of these should be, can you factor it? Right, that's the easiest route to go. And these you cannot, right? So you can't factor number 1, right? You can't get factors of 2 that add up to negative 4. So let's use the quadratic formula, right? So we want to label A, B, and C, right? So A is going to be 1, right? It's the number in front of the x squared. B is going to be negative 4, so the number in front of your x. And then C is your constant. It's going to be 2. All right, and then you want to plug it into this formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. All right, so again, it might seem like a lot at first. Maybe you remember it from Algebra 1. If not, and you're seeing it for the first time, all right, commit this to memory. You're going to be using it a lot. All right, so for this one, let's plug in negative 4 for b. All right, so we get x equals, or let me assign these colors. So we get x equals negative 4, right? I won't write it out like this every single time. I just want you guys to see where each piece goes, right? So plus or minus the square root of negative 4 squared, all right? And this is minus 4, and a is going to be 1, so 4 times 1, and then c is 2 times 2, all right, over 2 times, and a is 1. All right, so I kind of color-coded things, right? You should see where each piece goes. Now we should get an answer after evaluating this and simplifying the square root. So we should get x equals negative 4 is going to be plus 4. So it's going to be x equals 4 plus or minus the square root. Negative 4 squared should get you a positive 16. Minus 4 times 1 times 2 is going to be minus 8 over 2 times 1 is 2. All right. And now we can simplify under the radical and just simplify this entire answer. All right, so this is going to be 4 plus or minus the square root of 8 over 2. And then square root of 8 you can simplify, right? What perfect squares are in the square root of 8 is going to be square root of 4 and square root of 2. And then square root of 4 becomes 2. So then this becomes 4 plus or minus 2 square root of 2 over 2. All right, and now we want to simplify a little bit further, right? So you might want to leave it here, but if you remember from our radicals section, we can treat this radical like a variable, right? So between 4 and 2 squared root of 2, do they share a common factor? right? They should share a factor of 2. So if you take out a 2 from everything, you can cancel it out with this 2 on the bottom, right? So cancel out a 2 from everything. We should get a 2 and a 1 in front of this square root of 2, and then the 2 on the bottom goes away. All right, so we should get our answers as x equals 2 plus or minus the square root of 2, right, as our two answers. All right, let's try another one. Again, by quadratic formula. Again, your instinct is going to be to check if you can factor it. All right, this one cannot be factored. There are no factors of -2 that add to -3. So let's label. All right, I'll label a equals 1, b equals 3 and -3, and c equals -2. All right, so we just want to plug it into this formula. Again, x equals -b plus or minus the square root of b squared minus 4ac over 2a. All right, just plug in all of these pieces. We should get -3, all right, plus or minus the square root of b squared, all right, so -3 squared, minus 4 times a times c, all right, all over 2 times 1. So 2 times 1. All right, this is going to be x equals. All right, I forgot that in the beginning. All right, so now let's simplify this. All right, so -3 is going to be +3, so we get 3 plus or minus 3 squared, or -3 squared is 9. All right, -4 times 1 times -2 is +8. All right, so that's going to be under the radical over 2 times 1 is 2. All right, so x equals this. And then 9 plus 8 should get you 17. And then there's nothing in 17 that can simplify. All right, so you only want to simplify this final part of it, right? You don't want to simplify, maybe you see this 9 and you want to square root that and then square root the 8, right? You can't do that. You can only do it when it's being factored, or when you have factors under the radical. All right, so you can leave your answer like this. So x equals 3 plus or minus the square root of 17 over 2. Right, there's nothing else that you can do to it, so this would be your final answer. All right, now looking at this next one, all right, as it's written, you can't really do anything to it yet, right? Because to be able to use the quadratic formula, you need the entire equation set equal to 0, right? So the first thing we want to do, let's subtract that 3 on both sides, right? And then we get 2 over 3x squared minus 1/4 x minus 3 equals 0. All right, and now we're ready to use the quadratic formula. Or no, we're not actually. Let's actually get rid of the fraction, right? You're able to use it. You are able to, right? I'm not going to say that you can't, because you can, right? You have an a, b, and c value here. It's in standard form, right? You're able to use it. But if you do, you're going to get a bunch of fractions, right? And I know you guys don't like fractions, so let's try to avoid it. Right, and let's avoid the fractions just by multiplying the entire equation by a common denominator. Now your denominators here are 3 and 4, so we want to multiply this whole thing by 12. Right, multiplying 12 to everything. Right, 12 times 2 is 24, divided by 3 is going to get you 8. X squared minus 12 divided by 4 is going to get you 3x minus 3 times 12 is 36. Equals 12 times 0 is 0. All right. And now we're ready to use the quadratic formula. Again, x equals -b plus or minus the square root of b squared minus 4ac over 2a. All right, so now let's plug in. We have an a value of 8, a b value of -3, and a c value of -36, right? So we just want to plug all this in. All right, so we should get x equals Negative b is going to be negative, or it's going to be positive 3, right? Minus a negative is going to be positive. So we get 3 plus or minus the square root. Negative 3 squared is 9. All right, minus 4 times a times c. All right, all over 2 times a, so 2 times 8. All right, and now from here, let's simplify under the radical a bit. We get 4 times 8 is 32. And then 32 times negative 36 is negative. All right, let me write this out. It's going to be, okay, so 3 plus or minus the square root of 9. It's going to be negative 1,152. All right, divided by 2 times 8 is 16. All right. And then we want to simplify under the radical a bit. So we get 3 plus or minus the square root of 1,161. And then divided by 16. All right. And now you want to check, can this radical be simplified? It actually can, right? You don't want to rule it out immediately. I know, oh, just because it's a big number and it looks kind of funny, right? It actually can be divided by 9, right? Now I'm going to go off on a separate lesson here, right? I think I went over this in one of the periods, but it's not as common knowledge as I thought, right? But if you add up the digits, right, now there's ways to tell if numbers are divisible by certain numbers, right? How do you know if a number is divisible by 2, right? Is if it's an even number, right? Even numbers are divisible by 2, right? If a number is divisible by 4, right, the last 2 digits of the number have to be divisible by 4. So for example, 324, right? The last 2 digits are 2 and 4, right? 24 is divisible by 4, so 324 is divisible by 4, and you get a whole number answer. Now, how do you know if a number is divisible by 3? Is if you add up all the digits and you get a number divisible by 3. Let's use the same number, 3, 2, and 4, right? Keep in mind, this is just completely separate, right? I'm just going off on a completely different lesson here. 3 plus 2 plus 4, right? If you add up all the digits, 3 plus 2 plus 4 gets you 9. If 9 is divisible by 3, then 324 is divisible by 3. Moreover, if 9 is divisible by 9, which it is, then 324 is divisible by 9. If you do the same thing with 1, 1, 6, 1, right? If you add up all these digits, 1 plus 1 is 2, plus 6 is 8, plus 1 gets you 9. So it's divisible by 3, and it's also divisible by 9, and that's what we're looking for here, right? And you can verify this, right? So 1161, if you type it in a calculator or you do it off to the side using long division, you should get a whole number when you divide it by 9. All right, and that whole number should be 129. So you get 3 plus or minus the square root of 9, the square root of 129, divided by 16. And then simplify this a little bit more, you get 3 plus or minus 3 square root of 129 over 16. All right, and there's your final answer using the quadratic formula. All right, so there's just 2 more examples here. All right, number 4. Right, first thing you want to check, is the entire equation set equal to 0? It is. The other thing you want to check, is it in standard form? Right, is this in standard form? This one is not, right? So we want to rewrite it in standard form. Let's move the 8x and the 10. All right, so plus 8x plus 10 equals 0, right? We want ax squared plus bx plus c. And this is equal to 0, and this is in standard form. So we get a equals 1, b equals 8, and c equals 10. All right, and then let's plug it into our quadratic equation, or quadratic formula, sorry. So we get x equals negative 8 plus or minus the square root of 8 squared, which is 64, minus 4 times 1 times 10, all over 2a, so 2 times 1. And then we get negative 8 plus or minus 4 times 1 times 10 is 40. And 64 times 40 is 24. And then over 2. All right, and then square root of 24, can that be simplified? Yes, it can. We get plus or minus. All right, it can simplify into 4 and 6, right? And 4 is a perfect square, 6 is not. So we get 2 square root of 6 over 2. And then just like the very first example, let's simplify this a little more. Treat the radical as a variable. Between negative 8 and 2, do they share a common factor? Right, they do. It's going to be 2, and it's the same thing as we have in the denominator, so let's divide everything by 2. Right, so we get negative 4, and then 2. And then we get x equals negative 4 plus or minus 2 square root of 6. All right, and then let's try one more. All right, now let's try number 5. You might want to, because of the way it's written, square root both sides, but you can only do that if you have a constant on the other side of the equal sign. In this case, we have an x with it. So let's actually, and since we're on the topic of using the quadratic formula, let's FOIL x plus 6 and x plus 6, and then move the negative 2x to the other side. All right, so let's FOIL this. We should get x times x is x squared, all right, plus 6x. Distribute the 6 to everything is another plus 6x plus 36, all right, equals negative 2x. We should get x squared plus 12x plus 36 equals negative 2x. All right, let's add the 2x on both sides. We should get x squared plus 14x plus 36 equals 0. All right. And now let's label, right? Now it's in standard form, and now the entire thing is set equal to 0. We get a equals 1, b equals 14, and c equals 36. All right. And now we want to plug it into the quadratic equation. So we should get x equals negative 14 plus or minus the square root of 14 squared minus 4 times 1 times 36, all right, over 2 times 1. All right, now let's simplify this a little bit further. We should get x equals, let me use a different color. All right, x equals negative 14 plus or minus the square root. 14 squared should be 196. And then 4 times 36 should get you 144. All right, so negative 144. And then divide the entire thing by 2. All right, and now we want to simplify this a little bit more. We get negative 14 plus or minus 196 minus 44 should be 56, or 52, I'm sorry. All right, square root of 52 divided by 2. And then let's simplify under the radical. 52. Does 52 have any factors that are perfect squares? It does. All right, so we want to make this into negative 14 plus or minus, right? It's going to give you a square root of 4 and square root of 13. All right, and then square root of 4 is going to be 2, square root of 13 you leave alone. All right, and then divide it by 2. And then just like the others, we want to simplify the top and the bottom, right? So the top, everything on the top can be divisible by 2. All right, so let's divide everything by 2. We should get negative 7, and then this goes away, and then the bottom goes away also. So we get x equals negative 7 plus or minus the square root of 13. All right, and that's solving by the quadratic formula. Again, the quadratic formula is going to be your all reliable, right? It's going to be useful in every single quadratic equation that you come across, right? Now, you can also solve by factoring, solve by square rooting, solve by completing the square when applicable, right? Those are, or at least factoring and square rooting are useful when you have an equation that you're able to do such a thing easily, right? But quadratic equation, or I'm sorry, the quadratic formula, and completing the square, you can kind of make it into a square root where you can take the square root on both sides, but the quadratic formula, if you memorize it, should be much quicker, right? This is something that's going to be useful in every single quadratic equation, right? You get your solutions every single time, all right?